Hello, Aniket. Am I audible? And screen is visible to everybody? Screen is. Please respond.
Sorry, your voice is not clear. The screen is also not visible.
Okay. Now,
So voice is clear, but screen is not visible.
please check now. Now screen is visible to everybody. Yes. Preeti, is it okay now? Hello? Hello, Preeti. Am I audible?
Yes, sir, you are audible.
Screen is visible.
No, sir, it's not visible to me.
I thought it could be a network issue
Yes, sir.
because at my end it is everything is okay. What
Okay, sir.
about others? Dhanasri, Krutika,
Yes, sir.
web, it is visible.
Yes, sir.
Yes, sir.
Screen is
Okay, okay. So in the previous lecture, we have started with the unit 4 and we have seen the types of stability, that is absolute stability and relative stability. So absolute stability is a qualitative analysis and relative stability is a quantitative analysis. So in case of absolute stability, instead of finding out the time solution, we can determine the stability simply by using the characteristic equation. Okay. Then in case of relative stability, this relative stability can be determined from the or it is related with the settling time and gain margin and phase margin to relative stability. Okay. Then now we are going to see the certain types of response. So basically, in control system, that is in any linear control system, in CS1 we are mainly dealing with the linear control system. We are not dealing with any kind of non-linearities in the presented in the system. Okay, so in this system, here we have used the Laplace transform. Okay, and we are using basically for analyzing the stability, we are using the S plane. Okay. So S plane is a complex quantity and it will be given by sigma plus j omega. Okay. So any time domain quantity can be converted into S domain or it can be converted into frequency domain. So S will be replaced by sigma plus j omega. So this is the complex plane sigma plus j omega. So with the help of this complex plane, we are going to analyze the stability of the system, whether our system is stable or whether our system is unstable. So we have seen in the yesterday's lecture. So we have seen the Hurwitz determinant. And for Hurwitz determinant, what is the sufficient condition? The sufficient condition is that all the roots, because we are determining the absolute stability. Okay, so absolute stability can be determined from the characteristic equation. Okay, and from this characteristic equation, so characteristic equation has its own roots. Okay, so here is the location of the roots. Based on that, the stability of the system can be determined. So therefore, the sufficient condition is that the all the roots of your characteristic equation that must be lie in a left hand side of your S plane. So this will be your this will be the imaginary axis, and beyond this side, this will be your left hand side of your S plane, and this will be your right hand side of your S plane. So if any one of the root of your characteristic equation is lie within this, or if all the roots are lie within left hand side of your S plane, then your system becomes stable. So therefore, uh, this is the imaginary axis, and uh, to the left hand side of this imaginary axis, this is called as left hand side of S plane. So if all the roots are lie in the left hand side of S plane, your system becomes stable. And if any one root is lie on the right hand side of your S plane, okay, then system become unstable. And if your roots of your systems are lie on imaginary axis, then the system are called as the marginally stable. That is called marginally stable. So that means, what is your observation from this? The location of the roots of your characteristic equation that decides the stability of the system. Okay, so we have seen the various step response and impulse response of first order and second order system. Okay, so in short, we just basically see the what is the effect of location of pole on the system stability with the help of impulse response and step response. Okay, so I just give you the one short table. Okay, so let's say first column is the nature of closed loop poles, nature of closed loop poles. Then second column is the location of pole, location of poles in S plane. Then third one is its step response. And last one is about the stability. Okay, so first we are considering if the nature of poles are real and negative. Okay, so if the nature of poles are real and negative, okay, so where is the location of poles in your S plane? Let's say this will be S plane, sigma plus sigma versus j omega. Here is j omega, and this could be sigma. So when poles are real and negative, that means your poles are lie on the negative real axis. Okay, so when they and these poles are located in the left hand side of your S plane. Okay, so at that time the step response for negative roots. Okay, so it could be like this. So this will be your step response. So that means your system become stable one. So we say that in that case our system is absolutely stable. So how we have decided that our system is absolutely stable? So here we say that when roots are real and negative, that means all roots are lie on the left hand side of the S plane. So therefore the system is absolutely stable. Okay, so it doesn't matter where is the exact location, whether it could be occurs at -2, -7, or infinity, minus infinity. Okay, so this is the effect. Then second case we are considering complex conjugate poles, complex conjugate pair of complex conjugate with negative real part, with negative real part. So where is the location of such poles in the yes here is j omega sigma in the S plane. Okay, so here we are considering this is the negative complex conjugate pole having negative real part. Okay, so this is the location. So here again, these roots are located in the left hand side of the S plane. So they are occurring in the left hand side of the S plane. So therefore, we have seen the step response in case of complex conjugate word for different values of zeta. You will see this like this response. So this will be the nature of step response that we have already seen. Okay, so here in this case again, as the oscillations are damped out with respect to time, so therefore system is again absolutely stable. Okay, so this is the second case. Then third case you can consider the pair of poles on imaginary axis, pair of poles on imaginary axis. Okay, so this will be your complex flow j omega sigma. So let's say this is our first pole and second pole. So now pair of pole on the imaginary axis. Okay, response could be like this, which is having sustained type of oscillations, constant oscillations. Okay, so therefore, in this case, your system become marginally stable. System is marginally stable, or sometimes it is called as limitedly stable. Okay, so if the roots of the characteristic equations are located on the imaginary axis, then in the step response is consisting of sustained oscillations. So therefore, in that case, the system is called as marginally stable. Then, fourth case we are going to consider here. I just rub this case, first case. Okay. So let's say fourth case. So fourth case is complex conjugate pair, complex conjugate pole pair with positive real part, with positive real part. Then where is the location of such pole? So the location of the poles are in right hand side of the S plane. Here is RHS. So therefore, how is the step response? So step response in this case are increasing oscillations with respect to time. So therefore, your system become unstable. So why here system become unstable? Because when you apply a bounded input, the output become unbounded one. So here BIBO principle may not work. So therefore, your system become unstable. Okay. Then last case, that is pair of repeated root on the imaginary axis, pair of complex conjugate with a pair of or repeated pair on imaginary axis. Okay, so where is the location? Here sigma j omega. So repeated pair on the imaginary axis. Okay, so in that case, again your step response could be of this type of nature. Okay, so again your system become unstable. So these are the few possible cases of different roots located in the S plane, and we have directly commented on the stability. So from these cases, it is observed that the location of the roots of characteristic equation that decides the stability of the system. Okay, so same way we will see for the impulse response. Okay, so that we are not going into the details of it, so we may go further directly next method. So in the previous lecture we finished with the determinant, and Hurwitz determinants have two major difficulties. One is the if the order of the control system increases, the times for determining the stability is also get increased. Then second disadvantage is that we cannot judge how many roots are located on the right hand side of the S lane. So this information we cannot extract from the Hurwitz determinant. Okay, so therefore these two difficulties are removed by the another method that is called as the modified root method, and therefore the name of that method is the Routh Hurwitz criteria. Okay, so previously we have seen only the Hurwitz determinant. Then the scientist whose name is Routh, he has developed certain new rules and minimized those difficulties which are present in the Hurwitz determinant. So therefore, the method name is given as Routh Hurwitz criteria. Routh Hurwitz criteria, or sometimes this method is also called as Routh array method. Array method. Okay, so please understood this method, which is very important as far as your examination point of view is concerned. Okay, so we start with the same. First we see the theory part. So in this method, simply we have to find out the two major steps. The first step is that we have to prepare the root array, and in the second step we are going to do simply a interpretation of the stability from the root array. These are the only two steps involved in the root array method. Okay, so first of all we first find out what is Routh Hurwitz criteria or root array method. Okay, so therefore we always start with the transfer function. Okay, so once again I repeat here, the transfer function of any system, it is the ratio of n of s upon the q of s, that is numerator upon denominator. So in general it will be given by b0 s raised to m, b0 s raised to m plus b1 s raised to m minus 1 plus dash 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 up to bn upon the characteristic equation a0 s raised to n plus a1 s raised to n minus 1 plus dash 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 up to an. So in general, the characteristic equation q of s is given by a0 s raised to n plus a1 s raised to n minus 1 plus a2 s raised to n minus 2 plus dash 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 up to an. So this is the in general characteristic equation, and characteristic equations are always equated equal to 0. Okay, so in general we just write down the characteristic equation, that is to give equation number 1 for this. So this is our in general characteristic equation, and this is the basis, because in absolute stability I have tell you that we can determining the stability from the characteristic equation. So here we are not finding out its time solution, because the difficulty is that if the order of the system increases, if your system is limited to first order, second order, it is very easy to find its time solution. But for fourth order, fifth order, it is very time consuming process. So therefore, how to decide the stability? So for that purpose, we are using this method, that is Routh Hurwitz criteria method. Okay, so within short time we can easily find the stability. Okay, so this is the characteristic equation. So similarly, we have seen the Hurwitz determinant. So in Hurwitz determinant, we have prepare one Hurwitz determinant, that is capital H. So here we have to find out the prepare first the root array. Okay, so how to prepare root array? So while preparing the root array, so your characteristic equations are arranged in a order such that, okay, so you start with your first element A0, okay, then alternate coefficient you have to consider. Okay, so let's say which are the alternate coefficient here, A0, then A2, this is next alternate coefficient, then again A2 के बाद में आएगा यहाँ पर A3, then A4 आ जाएगा, like this. Okay, so this is the element corresponding to first row of your root array, first row of your root array. Okay, and then the element in the second row, so that you start with A1. So alternate coefficient you can consider like this way. So these are the elements in the second row of root array. Okay, so in this way you can consider in the Hurwitz determinant, initially in the first row we have taken out odd element. Okay, here we are starting with जो भी s का जो भी पहला कोफिशिएंट होगा वहां से हम लोग फर्स्ट रो के एलिमेंट स्टार्ट करेंगे, वेदर ओके whatever is the respective power of s, whether it is even or whether it is odd, that doesn't matter. Okay, so in this way we can prepare a root array. So therefore, so in general we can write down element in the first row, element in the first row of your root array. So start with A0. So first element is A0. So alternate coefficients are always there. So A0 के बाद में A1 है. So you can skip A1. A1 के बाद में आ जाएगा आपका A2. Then A2 के बाद में आ जाएगा A3. So you can skip A3. Then आएगा A4. A4 के बाद में आएगा A5. Skip A5. Next one is A6 and so on. So in this way you can find out the alternate coefficient. So these are the element in the first row of your root array. So we are using simply here a alternate coefficient. Then similarly in the second row, okay, so second row you will start with first coefficient छोड़ के दूसरा coefficient. So A1, so A1 के बाद में आ जाएगा आपका A3, A3 के बाद A4, यहाँ पर आएगा A5 and so on. A6 के बाद में आ जाएगा A7 and so on. So these are the two in general elements of your first two row of your root array. So in the first two row we are using simply a alternate coefficient of your characteristic equation, and this is the simply basis of finding out the or preparing the root array. Okay, so in general we are going to prepare the root array and how to complete it, so that we are going to see. Okay, so let's take here we are taking any here is the order of the system is nth order. Here we are taking simply any arbitrary order system. So let's say it is highest power of es is 6. Okay, so you just write down complete up to the s raised to power 0. So s raised to 6, s raised to 5, s raised to 4, s raised to 3, s raised to 2, here s raised to 1 and s raised to 0. So in this, so this is the powers of s in the root array, and no one power of s should be absent in the while preparing the array. Okay, so that we will see if it is absent what will happen. Okay, so first two rows are, what are those first two rows? So these. Okay, so therefore you can write down directly. First row elements are A0, A2, A4, A6. Then second row elements are A1, A3, A5 and A7. Okay, so A7, if it is a sixth order system, then A7 may not be present. Okay, so it could be 0. Now, यहाँ तक किसी को डाउट है how to prepare a first two row of your root array? Do you have any doubt? So first two elements in the Routh array, these are the alternate elements of your characteristic equation. Okay, so this is your characteristic equation. In this way, we have prepared the first two row. Okay, so this will be your first row of Routh array, and this could be second row of your Routh array. Then rest of the element, how to complete this Routh array table. Okay, so how we are going to prepare it? So I just give you the formula. Okay, so I can consider here any arbitrary value, say b1, b2, b3, 0. Similarly, these are the values corresponding as for c1, c2, 0, 0. Okay, then s raised to 2, it is d1, d2, 0, 0. S raised to 1, it is e1, and s raised to 0, it is f1. Then all rest of the values are 0. So here in this way we have completed this table. Okay, so what are the values of this b1, b2, b3, b4 and c1, c2, c3, c4? Okay, so a1, a2, first two rows are known to us. Then how to find the value of b1? Please note down here. Whether my screen is visible to everybody? Yes? Hello? Okay, so how to find b1? Please reply whether my screen is visible and audible.
Yes, sir.
Okay, so how to find b1 element? Okay, so while finding out b1 element, okay, so what you have to do? Okay, so you have to first take the multiplication of a1 to a2. Please note down this. जैसे आप डिटर्मिनेंट फाइंड करते हो, so while finding out determinant of the matrix, we will do the multiplication a0 into a3 minus a1 into a2 upon the determinant. Okay, so therefore here while finding out b1, just make the cross multiplication of a1. So here you can consider b1 के ऊपर वाला एलिमेंट है आपका a1, so consider this a1 as a base element while finding out b1. Okay, so therefore b1 will be given by a1 into a2. So therefore first cross multiplication will be given by a1 a2 minus the second cross multiplication is a0 to a3. Okay, so therefore second thing is a0 a3 divided by the base element है आपका a1. So therefore divide it by a1. तो आपको जो भी नेक्स्ट रो है, अभी आपको एस रेस टू 4 के करस्पॉन्डिंग एलिमेंट फाइंड करने हैं. तो फॉर दिस एस रेस टू पावर 4, इसके लिए a1 ऑलवेज यू कैन कंसीडर एज अ बेस एलिमेंट. ओके, देन सिमिलरली while finding out b2, so can you tell me the formula of b2? B2 कैसे आएगा? Yes, anybody? Yes, B2 कैसे आएगा? तो B1 क्लियर हो गया सबको? Okay, so while finding out B2 element, so you just make the cross multiplication of A1 as a base element. So therefore multiply A1 to A5. Sorry. Yes. Multiply A1 with A4. Okay. So therefore B2 will be given by A1 into A4 minus next one is A0 into A5. So this will be your second thing. A0 A5 divided by A1. Okay. Similarly, you can find B3. So tell me the values of B3. B3 का कैसा आएगा फार्मूला?
A6
तो A0 A1 you can consider as a base element. So therefore पहला प्रोडक्ट क्या आएगा? अभी A1 से A4 को मल्टीप्लाई किया, so remaining रूट हैर में कौन से एलिमेंट बचे? A6 and 0. So therefore multiply A1 with A6. So therefore पहला एलिमेंट क्या आएगा? While finding out B3, A1 into A6 minus अभी क्या आएगा? A0 से 0, तो A0 into 0. Okay, so A0 into 0 divided by A1. Okay, so B1, B2, B3 gives you the element in the third row. So अभी third row आपका complete हो गया. Then go for the next row. So next row आपका corresponding to S3. तो आपको coefficient find करना है C1, C2. Okay, so same formula you can apply. So tell me the value of C1. तो अभी C1 फाइंड करना है, तो बेस कौन सा रहेगा? B1. उसके अपर वाला जो भी रो रहेगा वो, तो B1 into A3. तो नेक्स्ट आएगा आपका B1 into A3 माइनस A1 into B2. A1 into B2 डिवाइडेड बाय बेस रहेगा आपका B1. ये हो गया आपका C1. Similarly, you can find C2. अभी C2 कैसे आएगा? This element again B1 multiply by start with B1. So B1 into A5 or A1 into B3. Okay. So write down C1 equal to B1 A5. B1 A5 minus A1 B3 divided by B1. So tell me the value of D1. So this is a simply basis of while prepare how to prepare a Routh Hurwitz. So this is a simple process. तो अभी D1 क्या आएगा? D1 के लिए while finding out D1 which is the base element, उसके अपर वाला C1 और B1 these are the base element. Okay, so पहला प्रोडक्ट किसका आएगा? Yes. C1 into B2. Okay, C1 into B2 minus here B1 into C2. B1 into C2 divided by base आपका रहेगा C1. So therefore divided by C1. ये हो गया D1. Okay. अगर D2 फाइंड करना रेस्ट ऑफ द एलिमेंट 0 है तो 0 आ जाएगा. So we can find E1. So tell me the value of E1. E1 is the row corresponding to S raised to power 1. तो उसके ऊपर के दो रो है D1 और C1. So these are the base. So D1 into C2. So here E1 into C2 and C1 into D2. So therefore D1 C2 minus C1 D2 divided by D1. So likewise, so these are the process. This is the simple process to complete the Routh array. Okay, so please note down these formulas. Okay, so in this way here, this is the first step. So for Routh array or Routh Hurwitz criteria, how to determine the stability. So these are only simple two steps are there. The step one is that in the step one, you just determine or preparing a Routh array. Just prepare a Routh array. This will be your first step. And second step is that step 2 is the interpretation of stability. Interpretation of stability. Interpretation of stability from Routh array. So these are the only two steps in the Routh Hurwitz criteria. So with the help of these two steps, we can easily determine the stability. Step 1 में आपको find करना है, prepare करना है Routh array. Once you prepare a Routh array, in the second step, we are going to determine from this Routh array, we can find out the stability. So how to find out, I can tell you. So you just note down this Routh array and note down the sample formulas of it, how to complete the Routh array. So after that, we will see how to comment on the stability from this Routh array. So after when you finish it, just tell me. अगर किसी को डाउट होगा while doing the calculation of B1, B2, B3, C1, C2, D1, E1, F1, please tell me. Because this is the basis. So have you finished it? Shall we proceed? Yes or no? Hello? पर ये थोड़ा एक सवा पर. Yes, have you finished it? Okay. Nobody is ready to respond, so I can proceed. I can assume that everybody is finished with this. So here we have prepared the Routh array. Okay, so first step is over. Then next step is to how to determine the stability from the Routh array. So while determining the stability from the Routh array, so the most important step is that whatever the Routh array we have prepared, so first column of your Routh array is the very important element. So from the values of first column of your Routh array, based on the values we can decide the stability. So I just give you the example. So I just repeat this step. So s raised to 6, s raised to 5, s raised to 4, s raised to 3, s square, s1, and here s raised to 0. So what are the elements in of our uh, first column of your Routh array? So these are the very important elements, and with the help of those elements, we can determining the stability. So the elements in the first row are A0, A1, B1, C1, D1, E1, and F1. Okay, so elements in the first row, elements in first column of Routh array Routh array are used for stability determination, for stability determination. Okay, so how to determine the stability? So in these elements in the first column of your Routh array, we just find out how many number of sign changes, how many number of sign changes present in the first column of Routh array. So sign changes means what? Let's take an example. Let's say this B1 value is -3. Okay, so at that time, and all rest of the values are positive. Say let's say 1, 1, 2, 2, 3, 4, like this. So how many sign changes are there here? So here this sign is positive, this sign is negative. So therefore here is the first sign change, and then here -3 to -2, and here is the occurrence of second sign change. So that means whatever value we have considered here, there is the occurrence of two sign changes. So therefore, what is the meaning of these sign changes? So sign changes indicates the number of roots which are lie on the right hand side of your ES plane. So therefore here you just note down number of sign changes, number of sign changes in the first column must be equal to number of roots in right hand side of yes plane. Okay, so in this and from this information we can easily judge the stability of the system. Okay, so number of sign changes equal to number of roots which are located in the right hand side of the ES plane. So therefore, As there is no sign changes, that means your system becomes stable, and as there is a presence of sign changes, that means your system become unstable one. So system is unstable having two roots are located on the right hand side of your yes. So in this way we can judge the stability from the elements of the root array, from elements of the first column of your root array. Okay, so this is all about the basis of Routh Hurwitz criteria or Routh array method, and in this way we can determine the stability. Okay, so please note down this, so we can solve certain problems based on this. So take down the first problem. One simple problem you can take down. A closed loop control system has the characteristic equation. It will be given by s cube plus 4.5 s square plus 3.5 s plus 1.5 equal to 0. Okay, so find the stability. Find the stability of the system using Routh array method. Routh array method. Write down the solution. First of all, write down the characteristic equation. Here s cube plus 4.5 s square plus 3.5 s plus 1.5 equal to 0. So this is the characteristic equation given to us. So you always compare this characteristic equation with the standard characteristic equation. So here a0 into s raised to power 3 plus a1 into s raised to power 2 plus a2 into s plus a3, which is equal to 0. So here we are going to compare the given characteristic equation with the standard characteristic equation, and here we are getting the coefficient values. Okay, now prepare the Routh array. Okay, so first of all, find out the element corresponding to first row and second row of your Routh array, and Routh array consisting of all the power of s. Here s cube, s square, s raised to 1 and s raised to 0. So find the element corresponding to first two rows. So we are using the alternate coefficient. Start with first element. तो अल्टरनेट a0 के बाद में आएगा a2 के बाद में कोई नहीं है, so therefore these are the element corresponding to first row of your Routh array. Then start with the second row, second element of your characteristic equation a1 and then a3. So these are the element corresponding to second row. Okay, so now complete the Routh array. So first row elements is A0. So A0 coefficient is 1. So therefore 1. Then second alternate is A2. A2 coefficient is 3.5. उसके बाद में कोई है नहीं, therefore 0. Then second S2 के corresponding पहला आएगा A1. A1 का वैल्यू है 4.5. So here is 4.5. Then A3 का वैल्यू है 1.5 and then 0. These are the elements in the first two rows of your Routh array. So now find the elements in the row corresponding to S1 and S0. तो अगर आपको फाइंड करने में प्रॉब्लम जाता है, so you just give the name B1, B2, B3, C1, C2, C3 like this. So find the value of B1. So B1 कैसे मिलेगा? You can show in terms of arrow. So while finding out B1, your 4.5 is the base element. Okay, so 4.5 into 3.5. Okay, so therefore ये आएगा 4.5 into 3.5 minus this 1 into 1.5. So here 1 into 1.5 divided by 4.5. Tell me the value of B1. So now you can replace this B1 by that value. Please tell me the value B1. So B1 is
3.16.
3.16.
Yes, sir.
Okay. So here is 3.16. So similarly find B2. So B2 find करने के लिए you can show the calculation in terms of arrow. Okay. So B2 find करने के लिए start with your base value is 4.5. So therefore 4.5 into this. Okay. So therefore 4.5 multiplied by 0 minus again 1 into this. So 1 into 0 divided by 4.5. So this value is 0. So therefore B2 value is 0. Then similarly अगर B2 0 है तो B3 भी 0 आ जाएगा. Now next find the value of C1. Complete your Routh array. Tell me the value of C1. तो C1 फाइंड करने के लिए उसके ऊपर वाले जो वैल्यू है वो बेस कंसीडर करो 3.16. तो 3.16 into 1.5. So 3.16 into 1.5. Okay. Then next आएगा 4.5 into 0 minus 4.5 into 0 divided by 3.16. तो आ जाएगा 1.5. Okay. So therefore replace C1 by 1.5. So what is the value of C2? 3.16 into 0, 4.5 into 0. So it could be 0. Okay. So therefore replace those by 0, 0. So here we have completed our Routh array. Okay. Then what about the stability? S cube, S2, S1, S0. Okay, so 1, 4.5, 3.16, and 1.5. So whilst finding out the stability, what we have mentioned here, the elements in the first column of your Routh array is okay. So with the elements in the first column of Routh array, from these values we can determine the stability. So these are the values of your elements in the first column of your Routh array. Okay. Then how to find the stability? We have to observe the number of sign changes. So here this is positive, this also positive, this also positive, this also positive. So therefore, how many number of sign changes? Write down number of sign changes. Number of sign changes in the first column. The first column of Routh array इक्वल टू कितने हैं? कितने साइन चेंजेस है इसमें?
No sign change.
No sign change. So that means number of sign changes in the first column of Routh array is 0. Okay. So therefore, what about the stability? Whether your system is stable or unstable? क्या लिखा है यहाँ पर? नंबर ऑफ साइन चेंजेस इक्वल टू नंबर ऑफ रूट्स ऑन राइट हैंड साइड ऑफ द एस प्लेन. So number of sign changes are 0. Therefore, how many roots are located on the right hand side of the S plane?
0.
0. अगर right hand side of S plane में 0 root है, that means your system become
Stable.
stable. Okay. So therefore in the single line you just write down that as no root of characteristic equation. No root of characteristic equation lie on right hand side of S plane. Therefore, the system is stable. System is stable. Is it clear to you, everybody? Let's solve another problem. Then we stop. Let the transfer function of the system is given U of S upon R of S equal to twice S plus 5 upon S raised to 5 plus 1.5 S raised to 4 plus 2S cube plus 4S square plus 5S plus 10. Okay. So problem statement is find the stability using Routh array method. So first of all, write down the characteristic equation. Here Q of S equal to s raised to 5 plus 1.5 s raised to 4 plus 2s cube plus 4s square plus 5s plus 10, which is equal to 0. So write down the standard form of characteristic equation. So here a0 into s raised to 5 plus a1 into s raised to 5, sorry, s raised to 4, a2 s raised to cube plus a3 s square plus a4s plus a5, which is equal to 0. To compare these two equations, so with the help of arrowhead, prepare first row, element in the first row. So start with a0. So alternate, keep this a1, a2, a2 के बाद में आएगा a4, like this. These are the element in the first row. Then for second row, start with a1, a1, a3, a5. So these are the element in the second row. Now prepare a Routh array and complete this. First row s raised to 5, 4, cube, 2, 1, and 0. The first element is a0. A0 coefficient is 1. A2 coefficient is 2, 1, 2. Then A4. A4 coefficient is 5, 1, 2, 5. Second row elements are A1. So A1 coefficient is 1.5. A3 is 4. And A5 is 10. To complete this table, so here this element is above wala 1.5 is the base element. So 1.5 into 2. So in small letter I can write here 1.5 into 2 minus 1 into 4 divided by 1.5. Tell me this value. Three minus 4 by 1.5. It could be minus 0.66. Then similarly, second element, 1.5 into 5. Write down 1.5 into 5 minus here 1 into 10. So 10 divided by 1.5. तो सेकंड एलिमेंट आएगा आपका माइनस 1.66. थर्ड एलिमेंट 0 आ जाएगा. Tell me the element corresponding to S2. So element corresponding to S2 is here 0.66 into 4 minus 0.66 into 4 minus 1.5 into minus 1.66 divided by minus 0.66. तो ये वैल्यू आ जाएगा आपका 0.227 0.227. सेकंड वैल्यू आ जाएगा आपका 10. सेकंड रो की वैल्यू आई जस्ट ओमिट दिस. तो 1.66 के बाद में 10 0 0. S⁻1 के करस्पॉन्डिंग आएगा नेक्स्ट वैल्यू 27.4100 एंड देन लास्ट वैल्यू आ जाएगा 10. ओके, so here observe the elements in the first column of your root array. So this will be your first column of root array. Okay, so how many sign changes are there? Here is the first sign change. You can mark like this. First sign change. Here is second sign change. Okay, so therefore write down next as two sign changes are there in the first column of root array. Hence, two roots are located on the right hand side of the S plane. Hence, your system become unstable. So this is about the basics of root array method. So in the next lecture, we can see the two disadvantages or the two difficulties associated with the root array method and how to minimize it. What is the solution of it? So today we stop here.